All right. Hey, everybody. We are in the next lesson, 11.2 of our Tennessee Revealed Geometry area of regular polygons. Okay, listen, if you are a brand new teacher, your students are going to struggle with this lesson. So you're going to take it really slow. And the reason I say that is this right there, the apothegm. Yeah. Well, if they are not comfortable solving triangles, or right triangles, they are going to, yeah, they're going to want to stay after school for tutoring. Okay, so let's take this slow. We're finding the area of regular polygons. Regular means that all of your sides are equal in measure and all of your angles are equal in measure. They're all congruent to each other. Okay. Oh, let's see. We're going to look at the center of a regular polygon. That's going to be called the central angle. We're going to look at the radius of it. But the radius and the apothegm are not the same thing. So students do need to be aware of that. The radius and the apothegm, not the same thing. All right. So let's see. And composite figures. I actually like composite figures. It's like a big gigantic puzzle to me. So I like things like that. All right, let's get into it. Center of a regular polygon is the center of the circle. It's the same thing really as a central angle. You're going to need to be able to find that. And to do that, you take 360 and you divide by how many sides or angles, for that matter, the polygon has. So 1, 2, 3, 4, 5. This sucker is a pentagon. So I would take 360 and I would divide by 5. That would give me the central angle. Now, you're going to end up having to divide that by 2 to get this little angle right here of the right triangle. Because technically what you're finding is this angle, this big angle. And so when you split it into a right triangle by drawing out the apothegm, which is this little segment to the center of that segment AB, that's the midpoint of AB, to make it a right triangle, you're going to have to take that central angle and divide by 2. So 360 divided by how many sides will get you this big angle P, and then divide by 2 to get the angle of this right triangle after you draw the apothegm. All right, so with that being said, the apothegm is not the radius. This is your radius. The apothegm is the segment that is from the center to the perpendicular side of AB or BC or CD, whatever, one of the sides of the polygon. All right, so let's, okay, we're not getting into it. Looks like I got the formula. Okay, so the formula for the area of a regular polygon is 1/2 your apothegm times your perimeter. Perimeter is when you add up all the sides. Now, you're probably going to have to use trigonometry to find the apothegm unless they are being nice to you and they give you the radius, and then you'll be able to do the Pythagorean theorem. But 9 times out of 10, they don't be nice to you. So they're not going to give you the radius, and that means you're going to have to use trigonometry with this angle that we just talked about and this little side, which is half of the length of the side of the polygon, and tangent formula to find your apothegm. All right, here goes. Example number 1. All right, in the figure, regular hexagon, JK all the way around, is inscribed in circle R, R being the center of your circle. Identify the center. Okay, well, I just said it. The radius, the apothegm, and the central angle of the polygon. Then find the measure of the central angle. Okay, I got you. All right, the center is the R because anytime you name a circle, you name it by its center. All right, the radius, okay, they give me the answer to that, is RK. Well, it's actually also RL. So either one is good for me. All right, the apothegm of the regular hexagon is R to S. And it's going to be a segment. I think this is the one that's this segment, RS. All right, perfect. All right, the central angle is KRL. Or you could have said angle LRK, as long as R is in the middle, because that's your vertex. The regular hexagon has sides. Okay, I guess I just want how many sides it is. Well, if it's a hexagon, it has 6 sides. All right, thus the measure of the central angle is 360 divided by 6. So everybody, take 360, divide by 6, you're going to get 60 degrees. Now, remember, that is this big angle. Once we draw the apothem, we got to take that 60 and divide by 2 to get 30 degrees. So my angle right there is going to be, this angle is going to be 30 degrees. And this angle is going to be 30 degrees because 30 and 30 make 60. All right. Example number 2. Let me turn to the next page. Forgot to tell you guys where we were. We were on page 639 of the workbook. And now I'm going to turn the page and be on 640 of the workbook. So if you're following along with me on the workbook, or if you are on your page here in your ebook, depending on what your teacher does, it's the same stuff. All right, so example number 1, looks like I'm done. Let's go to example number 2. All right, so Lindsay created a patch for the robotics club at her school. The patch is a regular octagon. That means it has 8 sides. So we're going to end up taking 360 and dividing by 8. And the length of the side is 4 centimeters. So every single side is 4. That means from A to C is 4. That means from A to D is a 2. All right, we get to find the area of this octagon. And they want up to the nearest tenth. All right, well, step number 1, take 360 and divide by 8 because an octagon has 8 sides to get 45. However, that is the central angle ABC. It is 45 degrees. You're going to have to take that 45 and divide by 2 to get each one of these angles. So angle ABD, angle CBD. All right, so 45 divided by 2 is 22.5 degrees. That's probably going to be set in example number, or step 2. Yeah, there it is right there. All right, so 22.5 for ABD, 22.5 for angle CBD. And I've already told you that AC is 4, and that means AD is 2, and CD is 2. All right. First thing in the morning, my voice is not used to speaking. All right, here we go. This is going to be a tangent problem, like I said earlier. And the reason why is because it's a right triangle, which means it's either going to be sine, cosine, or tangent. I have 22.5 degree angle. I have its opposite side, which is 2. And I need the apothem. And this is the adjacent side to the 22.5. I do not have the radius, which is our hypotenuse, and I don't need it. What I need is the apothem. All right, so I have the opposite side to the 22.5, and I need the adjacent. Well, tangent is opposite. That's why the 2 is on top. Over the adjacent, that's why your apothem is on the bottom. And everybody knows that you can't take 2 and divide by A in your calculator, so you swap their places. I'm talking about the tangent of 22.5, which is your theta, and your apothem, and you take your calculator and take 2 and divide by the tangent of 22.5. 2 divided by tangent 22.5. As a reminder, remember your calculator has to be in degrees for this to come out correctly. All right. Well, I got about 4.8-ish, 4.8 and some numbers rounded after that. They chose not to do this. Okay, that's fine. They just kept it as 2 over tangent of 22.5. Not a problem. All right, so step number 3. The formula for the area of any polygon is 1/2 the apothem times the perimeter. All right, so 1/2. Step number 2 gave us the apothem, which is about 4.8. And they leave it as 2 divided by the tangent of 22. That's not a problem. Perimeter, 4 plus 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 4, or just 4 times 8, because there's 8 sides, is 32. All right, so now we're going to grab our calculators, multiply all 3 of those things, and you're going to get approximately 77 point, what, technically it's 254.834. Now they want it to round to the nearest tenth, so it'll be 77. The 5 makes the 2 round to a 3, so it'll be 77.3 square centimeters. There's your area of the patch for the robotics club. All right, so it looks like we are done with example number 2. We have a check coming up. All right, ceramics. Imani is crafting coasters for a local craft fair. Each side measures 4 inches. Find the area of each coaster. Round your answer to the nearest tenth if necessary. All right. Well, I'm a visual person, so I went ahead and took the liberty of going into GeoGebra and drawing this sucker out so I can see what's going on. Now, if you're not a visual person like myself, then woo-woo, not a problem. I'm going to kind of go through it both ways. All right, so first off, the formula for the pentagon, 1, 2, 3, 4, 5, is the same as the area of any polygon. 1/2 the apothem times the perimeter. All right, so we know we're going to have 1/2 times, got to find the apothem, and it's going to be multiplied times 20. And the reason why is because if each side is 4, and there are 5 sides, 1, 2, 3, 4, 5, perimeter is going to be 20. Add up 4 or 5 times, or just 4 times 5 is 20. All right, so now we got to find the apothem. All right, so I've got a pentagon here, and I know that my apothem is the segment from the center, and I'm going to eyeball this. I'm not going to find the center, and the reason why is because if I were to do this, say, like on a test, maybe like the ACT, I'm not going to have, this loveliness right here. I'm just going to give myself a rough sketch. I know that I'm going to have a right triangle. Yeah, I'm just drawing myself, something to kind of look at. So there's my 90-degree angle. So I've got a little right angle right there. The problem tells me that every side is 4. That means from A to B is 4. That also means A to G, or the side of my right triangle is 2, because 2 and 2 make 4. All right, so now I got to take 360 and I've got to divide by how many sides there are, because I do need the central angle here, but then I got to divide it by 2 to find the actual angle inside this right triangle. All right, so take 360, divide by how many sides there are, and the pentagon has 5. So take 360 and divide by 5 and you get 72. Now remember, this is your central angle. This is not the angle inside the right triangle. So now I got to take 72 and divide by 2 to find the angle inside the triangle. So everybody divide by 2 and you get 36 degrees. This angle right here is 36 degrees. Now remember, I'm looking for my apothem, not the radius of the circle, not the hypotenuse of the right triangle. I'm looking for my apothem, which is the adjacent side to the 36-degree theta. So there's my theta right there. This means it's going to be a tangent problem. So I'm going to do tangent of 36 degrees, which is my theta. Opposite goes on top, and that is my 2. The adjacent, the apothem to the 36 degrees is my unknown. That's going to go on the bottom. Can't divide 2 by an apothem that I don't have, so I'm going to switch their places. So I'm looking to take 2 and divide by the tangent of 36. So grab your calculator. Again, make sure it's in degrees, because if it's not, your answer is going to come out wrong. And of course, we don't want that to happen. So take 2, divide by the tangent of 36, and your apothem, I got about 2.75. So it's approximately 2.75 for my apothem. All right, so I did all of that to find this area. So everybody grab your calculator, put in 1/2 times your apothem times the 20 we got from the perimeter. And again, it's 4 times 5 because there's 5 of them. All right, it's approximately, and I want to round this to the nearest 10th, 27.5 because the 2 after the 5 does not change the 5. So I got 27.5 squared inches. All right, well, if you need another one of those, you can go online and get another one out of your ebook. And it looks like I am ready to go to composite figures. I love composite figures. It's like a big, gigantic puzzle to me. And I guess this is what really intrigued me when I was in high school math, and also was very frustrating. All right. So a composite figure is when you have multiple figures that are combined to make a gigantic figure, like this square, this hexagon, and this trapezoid. They add up their areas to make a area of the entire figure. So it looks like we're going to find the area of this square, find the area of this hexagon, find this area of the trapezoid, add them all together. All right. Well, I see a couple things are going on. I see little slash marks. That means that if one of these slashes is 9, they are all the same. They're all 9. All right. So for the square, 9 times 9 is 81. All right, got that. All right, now we got to find the apothem for this hexagon. All right, well, 1/2 the apothem times the perimeter. And if all of them are 9 and there are 6 of them, 9 times 6 is 54. There's your perimeter. All right, so we need to take 360, divide by 6, because there are 6 sides. Then divide that central angle by 2 to get the angle of the triangle, the right triangle. And you're looking at 30 degrees. All right, so it's going to be a tangent of 30 degrees. Now remember, we got to take 9, and when we draw the apothem, it takes 9 and splits it into 2 equal parts. So the 4.5 is the little segment right here. So we're going to have tangent of 30 degrees equals 4.5 divided by your apothem. Same formula we did here. Tangent of 30 degrees is going to be equal to 4.5 divided by your apothem. Take your 4.5, switch their place and divide by the tangent of 30. So 4.5 divided by the tangent of 30 degrees. That's going to get you your apothem. Now, they realize that it's a 30, 60, 90 special right triangle. And if you have your short side 4.5, all you really do is take a square root of 3 behind that to get your long side. So if you did it on the calculator, you got 7.79. If you remember your rules for special right triangles, you can leave this 4.5 square root of 3. Either way, you're going to multiply all of these things, and you're going to get approximately 175.37, yada, 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 yada. All right, area of the trapezoid. The formula is 1/2 the height, which is your 19, times the bases added together, which is 15 and the 9. And they were nice enough to do this for us. So I'm just going to grab my calculator and put in the numbers. And I got 228. All right, add them all together. All right, the area of the figure is the area of the square plus the area of the hexagon plus the area of the trapezoid. You know what? They don't even have a third blank. Yeah, they do. I'm sorry. It's right behind you there. Oh my gosh. All right, so I'm going to add 81 and the 175.37, yada, 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 and the 228 all together. You can't even see my 228. It's there. 2. Oh, nope, now it's there. My apologies. Add them together. All right, looks like I got approximately 484. And I'm at 3, 7. The 7 is going to make the 3 round to a 4. So it looks like I got 484.4 squared centimeters. All right, let's check. All right, I got a composite figure of a triangle, a pentagon, and it looks like a rectangle. All right. Well, let's see here. The formula for a triangle is 1/2 base times height. Now, I have the base is 3 because all of these are marked equal. And I'm going to have to find the height. When they don't make this one easy, do they? That 5 is the hypotenuse. It is not the height of the triangle. So I got to do 1/2 base times height for the area. Oh, me. Times the base times the height. Okay, so look, I got to do the Pythagorean theorem to find the height, which is a squared plus b squared equals c squared. Okay, so I'm going to say a squared plus 3 squared equals c squared, which is my 5 squared. All right, subtract 3 squared to the other side. So 5 squared minus 3 squared is 16. And the opposite of squaring is the square root. So the square root of 16 is 4. Now, if you were sitting there going, isn't that just a 3, 4, 5 triangle? It is. It's that Pythagorean triple we have talked about before. So this is a 3, 4, 5 triangle. So if you realize that already before I did the Pythagorean theorem, then that is just going to save you time on this problem. All right. So listen, if you're a new teacher, teach the students the 3, 4, 5 triangle. It's on the ACT. So they do need to be able to recognize the 3, 4, 5 triangle. All right, so if they did not recognize it, that's okay, Pythagorean theorem. So now I've got the things I need. 1/2 times the base, which is 3, and the height, which is 4. So half of 12 is 6. So the area of the triangle is 6. All right, so don't forget that, everybody. All right, we can do the rectangle pretty easy. 3 times 8 is 24. So we've got the area of the triangle is 6. We've got the area of the rectangle is 24. Now let's talk about this pentagon. Well, I still have my GeoGebra pulled up. There it is. So this 3 is what I'm going to end up changing because the pentagon's angle is the same. Take 360, divide by 5, and then they divide that by 2 to get the angle of the triangle. And then when you draw your apothem, 3 will cut in half to make 1.5. So the only thing I really got to change is this right here. I'm going to make it a 1.5 instead of a 2. So 1.5 divided by the tangent of 36. All right, you're going to be looking at, let's see, 2.06. So 2.06 for the apothem of this pentagon. All right, so the formula is 1/2 times the 2.06 times the perimeter, which is 3 times 5 is 15. All right, so grab your calculator, put in 1/2 times the 2.06 stuff we got for the apothem times the perimeter, 3 times 5 is 15. And so your area of the pentagon is about 15.48. Add it to the area of the triangle that we got was a 6. Add it to the area of the rectangle, which is 24. Remember, it's 3 times 8 is 24. And final answer, and they went to the nearest tenth, 45.8 makes the 4 go to a 5, so it'd be 45.5 square yards. Woo! All right, there's our check. And that finishes off page 641 if you're following along with me with the workbook. So I'm going to turn the next page and go to example number 4. All right, so I'm on page 642. All right, got example number 4 to get through and the check, and away you go with the practice problems. All right, example number 4, we got to find the area of this composite figure, and it looks like they're going to want us to do subtracting. Okay, so the big figure is a trapezoid. I'm going to find the area of this trapezoid. I'm going to find the area of the unshaded triangle here, and I'm going to subtract them. All right, there are composite figures on the ACT. So you're going to need to know how to do this if you're a student. All right, so let's get into this. All right, step number 1, we got to find the height of the triangle. So it looks like they took this little triangle, this unshaded part, and they turned it upside down so we could figure out, I guess, the height of the triangle. And we need it because the formula for a triangle is 1/2 base times height. So it looks like we needed the Pythagorean theorem to find the height. All right. This little 1 right here, I'm assuming is 1 and 1 to get 2. I don't think I like this very much. And the reason why is because I tell my students don't assume anything unless it's marked equal or if it's a rule that you already know. All right, so this little 1 right here, they are assuming is 1 plus 1 is 2 for the base of the triangle. So this little section to the left is a 1, and the section to the right is a 1. So Pythagorean theorem, 6 is our hypotenuse of this right triangle. That's going to be your C. So 1 squared plus your height squared equals 6 squared. Subtract 1 squared to the other side. So 36 minus 1 is 35. The opposite of squaring is the square root. It looks like we get our height is the square root of 35. And they were nice enough to put this into the formula, 1/2 base times height, the base being the 2, the height being the square root of 35. Well, the 1/2 and the 2 just cancel each other out because a number times its reciprocal is just 1. Times the square root of 35 is square root of 35. Okay, this is the area of the triangle. Now we got to find the area of the trapezoid and subtract this number. All right, the formula for a trapezoid, and they give it to us, 1/2 the height times base 1 plus base 2. Base 1 and base 2 are the parallel sides. So 5, 2, and 5 is 12. This base is an 8. All right, so 1/2 the height of the trapezoid is the height of the triangle plus this 1. It is square root of 35 plus 1. Bases are 12 and 8. Add all of this together, and they do not give it to me as a decimal, and they don't combine. So they do combine like terms, but they don't combine the things that are not like terms. Okay. Whew. All right, here we go. So this is the area of the trapezoid. We're going to subtract off the area of the triangle. All right, you guys. So a 10 square root of 35 minus a 1 square root of 35 is a 9 square root of 35. So if we're going to leave it like the ACT is going to leave it, it's going to be 9 square root of 35 plus 10. They're asking me to give it as a decimal. So if you leave it in my class, 9 square root of 35 plus 10, that makes me happy. If you are going to give it to me as a decimal, so do it. Grab a calculator, put in 10 square root of 35 plus 10 minus 1 square root 35. Hit enter. And it's going to be approximately 63 point. Now the 4 does not make the 2 round, so it's going to be 63.2 squared meters. But again, I like the 9 square root of 35 plus 10. Same answer, and it leaves it as a radical. All right, check. Last problem on the page, 642 at the bottom. And they want the area of this composite figure. All right, well, I'm going to find the area of the big figure, which is a parallelogram. And I'm going to subtract off the unshaded part on the inside, which looks to me, This is a rhombus. Yes, it is. It's a rhombus. All right. So I'm going to subtract off the rhombus, and that's going to give me the area of the composite figure. All right. The formula for a parallelogram is base times height. 14 times 9 is 126. All right. The formula for a rhombus is 1/2 diagonal 1 times, diagonal 2. So 1/2 times 14 times 9 is 63. Well, if you're sitting there realizing 63 is half of 126, and 126, which is the area of the parallelogram, minus half 63, the area of the rhombus, you should be looking at 63. So the answer is B, because 126 minus its half is its other half. 63 is the answer, because 126 minus 63 is 63. All right, there you go. Need another example? Get with your teacher and do one online. All right, you guys, I am done because the practice is on you. So you're on page 643, ready to do some practice problems. If you have any questions, if you're a brand new teacher, ask me. If you're one of my students, ask me. You guys have a great day. See you later.